had color television.
And how much? For what?
Color
TV, yeah.
65 had computers. 51% had dishwashers. 62% had color television and computers. 49% had color television and dishwashers. 31% had computers and dishwashers. And 30%.
Wait, computers and dishwashers, yeah.
And 30% had also.
What are we dealing with? Color TV,
Dishwasher and computers.
dishwasher, and computer. You know what? To make my life easier, I'm going to define color TV as X. I'm going to define computers as Y. No, A. Computers is B. And I'll define dishwasher as C, just to make my life a little easier. And what was the question?
List the categories of households not included in these survey results.
So what they want. What is it? Why are we still hearing that class? Huh? Because that's going to kill us. So what they want is this negative space, right? They want this, which is going to be equal to the universe minus the union of all things.
Right here.
Why are we having that sound? Like, we have a,
There's a humming, right?
yeah, do we have a phone off? Or like,
I think it's just the radiator or
we
something.
just forgot to turn off the
The mic.
mic? Oh, come on.
Oh, there you go, there you go.
Okay, so, did they give you the total number of people surveyed?
No, it's not percentage.
Oh, but it doesn't matter, it's percentages, so it's just gonna be 100 less, because it's gonna be, so this is gonna be, oh, did I write an equal sign here? This is a minus sign. So this is gonna be 100% minus NAD. Do you follow that? Does that follow? You do make, does that make sense? Because these are percentage of people surveyed. So there are, so if you shade all this in there, let's say it comes out to 80%, then guess what? 20% of the people surveyed don't live in these rings. That's all. So we just got to figure out the percentage of the rings, and we just use our little formula. And our little formula is always, our general formula is add in all the sets, right? Then take away all of the immediately underlying doubles, right? If you have 3 sets, how many ways can you take doubles? 3 choose 2. What does 3 choose 2 work out to be? 3. So we should have 3 doubles. That can go in with A with B, A with C, B with C. And then next, you add back in the layer underneath. It turns out to be the last layer in this case, right? If you have 3 objects, the last layer in this case is triples, and you have 3 sets. So if 3 choose 3, there's only one way that can happen. So you only have one option here. A intersects B intersects C, pulls it up. And so we get 100% minus this. So this is the shading of all the rings. Agreed? And then it's just arithmetic. A was 96%. I'm not going to write them as a percent right now. I'm just seeing. B was 65%. C was 51%. A and B. So computer and TV and computer. This was A with B, I believe, right? They just do it in order, I think, right? 63. And then they do A with C. Yeah. TV and dishwasher. TV and dishwasher is A with C. Please catch me if I'm making a mistake. What is that, 49? And we need a B with C. I guess this is going to be B with C. Computer and dishwasher, B and C. That's going to be 31%. Plus the middle, 30. And when you do all, this is a percentage. So percent minus a percent gives you percent. And what do you end up with? I'm not doing it.
90, 100 minus 99.
One person says 1. We need somebody else to verify. 336?
And there it's 99.
99,
100 minus 99 is 1.
I can do that part. I just didn't know that. That's 99.
99.
Okay, so that means that 1% lives in here. Right? And this whole shaded region here is the 99%.
There's a B part.
Huh?
There's a part B in the question.
Okay, what's part B?
Use a Venn diagram to find the properties of households in
Proportion.
proportion. Oh, sorry, yeah. Proportion.
Use the Venn diagram to find the proportion
Households in each category.
and households in each of the categories. They gave us all the categories. What do you mean? They're all there. I don't understand the question. They give us every single number. Right?
They just want us to use the number.
What do you mean? I don't get it.
No,
It's done.
it means separate, like each number, how much each one has its own.
Like they want, oh, like we gotta do this piece, for example?
Yeah, like that.
Okay, gotcha.
Am I supposed to
Okay,
write?
Yeah.
so let's do it.
Alright, now we can't see you, but like, then you can't like.
Okay, so this is 1, right? These are all percentages. I'm not gonna write percent over and over again. So typically when you do that, you work from the middle out. So what was the middle value? The middle value is 30, right? Okay, so let's say this is A, B,
That's better.
C,
No?
right? So
You
this
can see
here
that
is
part.
A intersection C. Where's A intersection C? It's 49. So if this whole thing is 49, then what does this have to be? 19, right? If this is 49, then this is 19. What's B with C? B with C is 31, which means this is 1. What's A with B? A with B is 63, so this is 33. Please double check that work. Now A is 96, so this is 63, 73,
Please put that in the channel.
82, 82, what is that? 8 is this 14?
12.
12, what do we put? Somebody else want to double check? Excuse me, double check that. B is 65, so this is 63, 64, I think that's
Just
one.
like this whole class.
And then C is 51, that would have been, yeah, that's 50, right?
1.
So this is 1. So that's it, right? That clear?
Yeah, thank you.
No problem. I want to basically finish everything to the point in 4 and 5 to the point where all we have to do now from now till then is just answer, like have you guys continue to do lots of questions. And I think we're almost there, but let me just be sure about it. Eric was, oh yeah, there are these questions. We should do some of those.
May I have your attention, please? Would all grade 9 classes with their teachers please proceed to the cafetorium?
So
Thank you.
4-1 we've done. 4-2 we've done the theory of. 4-3 we've done the theory of. 4-4 we have not. So somebody make a note. 4-4 no 4-4 we've done. 4-5 4-5 we have to look at. So 4-5 4-5
Test on Friday, quiz on
I don't know
Monday.
if I touched
Right there.
on
Oh,
5-3. 4-5 5-3.
Oh, no.
What was 5
You know, I can't remember the title. I think that's it. Okay, guys, if you want me to limit, your quiz to not everything?
Yes, please. Yes,
So,
just one question.
Just one chapter.
Just 1 second. Just one question.
Important parts of each chapter.
You want to leave? Let's do this. Let's leave out any Pascal's triangle for this quiz.
Alright, I don't know how to do that. Sounds
For
good.
this quiz, we'll leave it all out. And we'll just focus this quiz on combinatorics, not including anything.
Permutations, permutations.
You don't have to worry about the multinomial theorem or anything like that for this quiz. Multinomial theorem is not going to be on your test either, because I don't think the other classes have learned that. They've only
You're good,
learned
you're good.
binomial.
Okay, so
You don't have to leave
Okay,
it super
so
far.
don't worry about Pascal.
You're fine
So
like
what's
that.
4, 5 all about?
You're fine like that.
If I'm not mistaken, 4, 5 is using quote unquote Pascal's method. So, so here's, I think so. You can.
This
So
one's
Pascal is Pascal's triangle is a binomial triangle, right? We discussed that already, and it has a characteristic whereby you can get any value in the triangle except for the things, the ones on the edges, by simply adding together two numbers above. Okay?
Her head is in the way.
And
Shift it over.
there's a relationship, obviously,
First
between
remind-
that and the combinatorics. We've discussed it in terms of choosing and so on and so forth.
No, my head's
No,
not.
you're
And
good.
another way you can think about it, if, from a visual perspective with trees, is adding pathways. So they kind of take that idea to get you to a place where you kind of employ this Pascal's method, which just basically means adding things that come before to create a new thing by asking you visual questions. So for example, here's one. How many ways? Oh, can you let them in? And
Just move it up.
you move. How many can you get from A to B if you must always
Yeah.
from left to right? And I make some kind of funky shape.
You can just put these two highlights down lower so it's...
Move it.
You don't have to. You can try.
Just hold it like this.
Move it up.
Oh yeah, no, the tripod, yeah. No, this is the maximum it goes.
No, not like make it wider. Just make the whole thing. Shift it up.
Oh.
So typically,
No.
if you know what you're doing, just do it. In this particular case, I'm saying you always have to move from left to right. Hang on, I'm going to make things a little bit more interesting.
Sir, we have to copy that.
You don't have to.
But then how about this?
You can't.
Inception.
This.
Can
Alright,
you
just
Do your best.
How do you do
Okay, so let's talk about getting. We have to start here, right? We have to finish there. Let's get from here to here. You can follow a pathway this way, you can follow a pathway this way, you can follow a pathway this way. So there are 3 ways that you can get from A to this point. Agreed? That's pretty straightforward, right? So in the sense of a tree diagram, you can think of your journey as to get to node, if you want to call this a node, getting to node 1 already gave you 3 pathways. To node 1, right? To node 1. Give you 1, 2, 3 pathways. Let's find another node. Here's a node. How many pathways from this node to that node? There's one way, but the thing is, if you look at what came before, you still, relative to A, there are still three pathways, so you can think about it as like that, I guess. That's to get to node 2, right? So this 3 carries over. That's an important item. Do you guys understand why the 3 carries over?
Yeah.
Because that number is always relative to where you started. So even though there's only one way to get from node 1 to node 2, there were 3 ways to get from A to node 1. So relative to A, that number is still a 3. Now, does that make any sense? Now we move along. Let's see, how many ways can we get to this node? Oh, wait a minute. There were 3 ways to get to this, rather, to get to this node. This node can be approached from that node or that node.
So it would be 5.
How the hell do you come up with
That
5?
doesn't make sense.
3 Oh, okay.
There were 3 pathways to get you to here, right? And there were 3 unique ways to get
Oh, so
here.
you just add those 2.
Could we recap that one more time, please?
Yeah, there were 3 ways to get to node, whatever, 2, right?
Okay.
And then there were 3 ways to get to node 1,
Right.
okay? So, you can, remember, all of these numbers are always relative to A. This means relative to A. So then the question is, what is the new number here relative to A? How many ways from A can you get to this point? The answer is 6, because these 3 ways relative to A can get carried that way, but these 3 ways relative to A, these are unique pathways. So you just add the 2, right? We call it Pascal's method. It makes sense because the triangle, right, has that additive principle, right? You guys know what I mean? So you just follow down the line. Now this is drawn a little clumsily. Here's another node. Well, if you carry this, can you, oh, we gotta be careful here, right? Because you can approach this node from here or from here, right? So if you add these 2 together, you're gonna get a 9 over there. And what about to here, guys?
15.
9 plus 6.
I think 15 was good. Okay. Now, you have a violation here. This is no good here. Because you'll notice, I stipulated you have to go from left to right. So based on my stipulation, if you follow along here, you have a violation, right? At some point, you have to go from right to left. So that's non-allowable path. So that is a no good path right there.
So you just
Why is
So in
it-
other words, this 9 over here,
I have to go start.
this 9 cannot get to there from here. Agreed? You guys see that? Because if I do that, I'm violating
You start going.
that rule. So I threw that in there as a little trick. Now you see that? So no go there. But maybe there's another way I can get to, I don't know, this node. Well, there's a 15 there. The 9 won't go.
so
But the 15 would go, right?
Yep.
So I think the only way I can get there
Is 1.
is the 15 carryover,
16.
right?
Sir,
Yes.
would you consider that as a node?
Which one here?
Yeah.
If you want to, sure. You can make as many nodes as you want.
So 15.
But you can call this a node, this a node, this a node, but they're all going to be carryovers of 15, right? So I don't see any other, correct me if I'm wrong, is there any other way of getting there?
No.
Other than without violating that rule?
No.
So then 9 basically died right here. Right?
Suicide.
The 9 just died right there. Because, and it makes sense, because your objective is to get from A to B following those rules. So basically, although that 9 pathway facilitated a fair bit of progress, apparently it's not, oh no, but it did die, because it's folded into the 15, right? It's folded into the 15. It just can't go any further than this. Okay? We've got our 15 over there. This 15 simply carries along to here. Can this be fed by anything else? It could be fed by that, but that would be moving from
It's the same.
right to left. So that 15 is just going to carry over there, right? And moving down the line this way, the 2 15s are going to feed that. Agreed?
And it's just 30 till the end.
60.
Now be careful, right? Because this 30 will take you this way. So this 30. So there are 2 unique ways to get to this point. But this point carried 30 unique ways from
The other.
before it, so it's like a double of the 30. Right? It's like 2 branches of 30 leaves and 30 leaves. So you get a 30 that way, and you get 30 that way. So that takes you to 60, and then if you carry that through, you get 60.
That's so cool. That's so cool.
Okay? So what's called Pascal's method. There is, and so they do similar questions with like checkerboards and all kinds of stuff. You guys can try some of them. There's one question in particular that is a lot of fun. I have done it. I hate doing it. It's page 259, question number 17. I have the answer that I wrote by hand like 2 years ago. I don't recommend you do it unless you're ready for a little bit of pain. Page 259, number 17. But all of the other stuff is fair game. Having said that, if you want to try 259, number 17, you can. I have the answer and I can go over the principle with you. It's about having a cascade of buckets, like one bucket, then another row of buckets of 2, then 3 staggered. water's pouring in the top. And then I think what was the question? How much water is used once you fill up
The bottom bucket.
at least one of the ones in the bottom?
Yes.
So the reason why it's tricky is because if you go through the problem, what you will see is that a bucket could be receiving water, let's say, right, at a particular flow. Let's say a bucket is getting water from one bucket. So it's getting water at a certain flow rate. But you'll find that as you get down in there, like by level 3 or whatever, it gets tricky because you'll have a bucket that's, let's say, half full. It's not filled yet, but then it starts to receive water from another bucket on top of it. So the flow rate into that bucket changes. Do you know what I'm saying?
So it's like the Pascal triangle?
It is similar to Pascal's triangle, yeah, in that in the method that you're adding, but it's tricky. I did it by working forwards. That's the way I did it. I just said let X. The way I did it was I was like, okay, let X be my flow rate in liters per minute or whatever. And then I was like, okay, well, that flow rate is going to go into these two. This is the easiest part. And then it gets split into, you know, X over 2, X over 2. Agreed? So like when this gets filled, right, then it will start to pour into here and at half flow. That's easy. But what starts to get tricky is this still is easy as well, because here you can say, oh, well, this is going to get split into X over 4, because this is X over 2 and a half, or X over 4. And you can say, oh, well, this is going to get an X over 4 and an X over 4, which will give you a total of X over 2 down the middle, right? This is X over 4, okay? But the tricky part is now, because if you think about it, this one is getting filled at twice the rate that this one is getting filled, right? The guy down the middle is getting filled at twice the rate that the ones on the end are. So this one's good. When this one is filled, right, these ones are going to be only at half. You see what I mean? And so the problem is that now when you talk about a bucket here, bucket here, bucket here, bucket here, well, these two start getting water initially, immediately from the center, right? And if this is coming in at X over 2, then these are going to get at X over 4. But that's only to start, because the moment these are filled, guess what? These start to pour over as well. Furthermore, while these are getting water, these are not yet getting water, because they will get, so you see how you have to keep track? So, but it's fun, but it's annoying, but it's whatever. It's up to you. If you want to try it, by all means, try it. The way I did it was I literally just drew out the buckets, like all empty, like all of them, and I photocopied it, because so that I had, because I worked linearly from the front. So if I made a mistake, I didn't want to have to I wanted my diagram to still be okay. So I'd like work through like, let's say 3 levels, or I'd work through to here, and I'd leave that as a picture. And then I'd go to my next picture, write everything, and I would continue. That way, if I make a mistake, I don't have to erase everything, because I want to maintain this information. Whatever.
So is the answer at the back, right?
Yes. I mean, that's what I got, and Mr. Gallo got it as well, so should be right.
Is the water in the first bucket continuous, or?
Yeah, this thing is just like a faucet. It's just going. So I think they ask in the end, oh yeah, how many liters? What's the question?
How much water will have been poured into the top bucket when at least one of the buckets in the bottom row is full?
Right, so in other words, how much got poured in here from the beginning when at least one bucket in the bottom is full, right? So
the others come around.
So it's easy, because the moment you get to the bottom level, the moment one fills up, you stop, and then all you have to do is add up the amount of water you have, right? So you'd be like, oh, well, that's a full one. How much is each bucket? 2? 2. So you'd be like, that's 2, that's 2, that's 2. But you're going to get to a point where you can see, oh, one on the side might be only like a 16th full, right? One down here might be like a 32nd full, right? You see what I'm saying?
That's disgusting.
It is disgusting. Very disgusting. Okay, there's that. I'm going to let you guys work this period. I'm just going to show you what. Let's just take, what was that other section? 5.3? We looked at problem solving with combinations. What a stupid general title for a section that means nothing. Everything we've been doing is problem solving with combinations. Okay, 5.3, I basically taught you. So 5.3 you can just do with the other things, and again, you'll have questions you will ask me.
Mr. Segev, can I just go to the back and do my own?
Yeah, so I think that, look, there are a ton of questions that we have to go over, right? Together, you're gonna have a lot of questions, but at this point, I think I have talked enough. I think you guys can start trying all kinds of questions from all over the chapter. You've done so for a lot of stuff. And then, you know, as you like, I'll take them up individually or on the board and stuff. Is that all right? You don't need me for theory. Now you need to work, feel a little bit of pain, struggle, work with each other, ask me for help, you know, and then we'll get there. Just. That's one of the joys of being in the front. Orders, I guess from left to right, with letters in Word Canada, with the restriction, right? What's the restriction? What's the restriction? Something like the A's can't move or the consonants can't move?
Consonants always be where they occur.
All the consonants cannot.
Oh, and G cannot move. And H can.
They can't move or they can't change order?
Am I in the way?
Okay. C and D order can't change. You guys
They
get
don't
it?
look the same, so like, what is that's so stupid? What?
No, it's not stupid. It's a good question.
But it's just that all the eight words distinguish the eight, and there's more
The
possibilities.
C and D orders.
okay.
But they're not usually distinguished.
So there are different ways you can do this question. So I'll let you think about it for a second, and I'll come up with a solution. You guys come up with a method. I'll come up with a method.
What's 3B3?
This is an important concept now, actually. I just realized this is an important concept.
Wait.
Could be C and E.
Because I keep passing it, I keep passing it.
Okay, here's the way I'm going to do it. Okay, and this is an important concept because it's a bit of a visual distinction. Typically, I have taught you guys about having, let's say, n objects and r positions, right? Whereby you can have even, let's say, 10 people, but you only take 6 of them, right? This is the same concept in terms of the way I'm going to solve it. I'm not saying you have to solve it that way. But visually it's different because what I'm going to do is I'm just going to deal with the A's right now. Okay? I'm going to deal with the A's. So in other words, I'm going to think of, if this is, I'm going to call this a position 1, position 2, position 3, position 4, position 5, position 6, and I'm going to, let's see if this thinking works. Like, I could fill these, how many A's are there? 3? 3 A's. I could put them there, or maybe I could put them there, or maybe I could do that, right? So, how many different ways can I slot the A's? I'm going to think about it like this. I'm going to make my positions n now. It's backwards now. So, I'm going to make my position, I want you to pick, it's like, which of these 6 positions am I going to choose to fill up with an A? It's kind of backwards, right? You see what I mean? Because we typically call positions where you throw stuff into, right? It's like, oh, I'm going to take these 3 people and put them into those positions. Now, visually, I'm working in the opposite way. I'm like, which of these 6 positions am I going to allocate to the letter A? Do you guys get what I'm saying? Yeah. It's backwards. So in this sense, now my positions are my n. Oh, you see? My positions are my n, right? Does that make any sense? Yeah,
I thought the order of C and D can't change.
that's coming up.
Okay.
I don't think it's very hard. So
Well,
we'll see if I'm right. I could be wrong. We'll see if I'm right. So if I have 6 positions, I want to take 3 of them, right? And I'm going to call this x. This means allocating 3 of 6 unique positions to be filled with an A. Does that make sense? So in other words, I could go AAA, or I could go AAA, or maybe AAA, right? There are a lot of different ways I could do it, right? Does that make sense so far? Now, let's say I slot in A. So this creates a tree, right? 6 choose 3 is, I don't know, 6 by 5 by 4. Yeah.
you're gonna divide it by 3 factorial because they're the same.
Yeah.
That's at the end.
Yeah, if you divide it, then you get the answer for that.
No, wait a minute. 6 choose 3. So yes, we do have to divide it by 3 factorial because right now. No, wait a minute. Let me think about it. I'm just thinking about my line of thinking. 6 choose. So 6 choose 3 means that this is one branch, right? This means P2, P4, P5. But I could have this as a branch, right? I think so far in terms of my line of thinking, I don't think I have to divide yet. Based on what I'm doing, I think this is still okay. So I'm gonna leave Wilson. What I've got here for my 6 choose 3 is just which 3 of the 6 do I stamp? I'm thinking of my AAA as a stamp. Which of those ones are gonna be stamped? Yes.
Sir, do we consider each A as a different level? Like A1, A2, A3?
No.
I'm not. No.
I'm
not.
A is just considered as one.
I'm not. Look, allocating, I'm calling this move, we'll see if I get the answer that he's talking about in the end. I'm calling this move allocating 3 of 6 unique positions to be filled with an A. So it's like, what does that come out to? What is that number?
120.
120?
Yeah.
Okay, so I'm picturing literally 120 branches where, you know, like one of the branches is A, maybe A, boom, boom, boom. And then another branch is like, I don't know, 1, 2, 3, 4, 5, 6, A, and so on and so forth, right?
So it doesn't matter.
That's all I'm doing so far. Well,
Sir, it's just 20.
Yeah.
63 is 20.
sorry, it's 20.
Wait,
120 is 63.
20. Okay, so now here's the thing. Can you be quiet for 2 seconds, please? Now, the only letters left to slot in are C, N, and D, right? But they're saying the order has to stay the same. So could I do this, C, D, N? Is that allowed?
No. Yeah.
Could I do D, C, N?
No.
How many ways can I fill in the rest of the spaces for each of these branches? One way, right? It's got to go C, N, D. Even if I went this way, for this branch, the AAA branch, maybe it's over here somewhere. Maybe it's 1, 2, 3, 4, 5, 6, A. The only way I can fill this in is one way, C, N, D, right? So coming off of this branch, guess how many branches you get? 1. You only get single branches coming off of each of those 20 branches. So does that change the number?
No.
So I would disagree with you, Milad. I would say that this is the answer.
I thought it said P, sir. You were.
Huh?
I thought you said 6P.
Where did I say 6P?
No, sorry.
6 choose 3.
You're right, sir.
Okay, so now this brings up a very important point. This is good that we had this exchange. You know why? because there are different ways you can solve these things. So if your logic is good, even when someone tells you you're wrong, you may be wrong, but you noticed I didn't waver from my answer so fast, even though he said I was wrong, because in my mind, my logic was pretty solid. So all I thought, hang on, maybe he's right. Maybe there's another move I have to make later, and maybe it'll all balance out. So one lesson you can take away from this is, and this, like whenever I teach this stuff to whomever, like it's all about whatever pathway you pick, it's got to make logically sound sense. Come up with somebody want to come up with another solution method? Okay, Milad, you have another one?
I did all the cases that are possible with C and D.
All the possible cases for slotting in C and D? Okay, so you went backwards. You put in C and D first. Okay, can you take us through your methods? Okay, take us through how you did that.
Okay, so I basically draw all the C and Ds, but after a while it's going to be the same because you are putting 3 A's, but when you took those C and D slots, you're putting 3 A's. Anyway, so that's one way of putting those 3 A's in the other spots.
Okay.
So I just get to count how many ways I can put C and D's.
And then the rest is not, it's just a single branch.
Yeah, and I counted and I found there are 20 ways to put C and D.
But you did it? You drew them?
I did it myself.
That's too.
That's basically how all the.
How about this? How about this? One sec, Tony. How about this? I want to use Milad's method I'm going to do Milad's method in a slightly different way. Again, you have 1, 2, 3, 4, 5, 6 positions.
So you can show A as A1, A2, A3, B6, B3, and divide by 3.
The letters are different, right? So you could do something like this. You could say, I suppose, 6P3, because you could say there are 6 unique, now again, it's flipped to your positions, right? To your positions really means the end. So I should say, note, in this queue, positions are the n factorial, right? Where no, good enough. Okay? Because we're used to the positions being the r. You see the distinction there? But okay. So I could do this, I could say 6p3 because I have 6 positions and I have 3 unique letters. 3 unique letters, right? To allocate. So like what this is saying is like if you went C and D, if you used up these 3 slots, this is going to count that as a branch, but guess what? It's also going to count that as a branch too, right? Even though the same 3 are filled up. But guess what? So if you think about it, 63, this is going to be, instead of 20, it's going to be multiplied by 3 factorial by 6, right? It's going to be 120, right? So now in this case, for this you get 1, 2, 3, da, 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 da. In this case you get 120. But the interesting thing here is if you look at the tree 1, 2, 3, 4, 5, 6, how many cases are there going to be where the first, in this number, your name again? Anthony, in this number of 120, how many cases are there going to be in the 6B3 where the first 3 slots are used up? 6. CDN, NDC, 3 factorial, right? There are going to be 6 ways that the first 3 slots could be used up in this calculation, right? But the thing is, so it could be like CDN, it could be the CND, it could be 1, 2, 3, 4, 5, 6, DNC, and so on and so forth, right? But guess what? In this question, only one of the orders is allowed. So you could take those 6 orders and squash them down to 1. I also would go for, if you use these 3 slots, C, D, N, for example, how many ways can the last 3 be used? 6. So if you look at each of those as a unique cluster, like where you think of the last 3 slot cluster, or the first 3 slot cluster, the middle 3, or 1, 2, 3. Each of those are a clump of 6 that has to be squashed down to 1. So you can take all this and divide by 3 factorial. Now, regardless which of the clusters you're talking about, the only job you have left to do is fill in the rest with A's. But how many ways can you fill in the rest of the slots with A's? 1 way. So you don't have to do anything else here. So that is the same as that. So that's what you did, but you don't actually have to count them.
I have another way too.
Okay, let's try the other way.
You can think of it that C, D, N, you can say let's say they are all the same. So you're going to choose to put them in there, and it's going to be the same as the right side.
Yeah.
But then you're going to say, okay, I have only one way to put them, so I put C and D.
Yeah. Yeah. Now, I give you this question because there's a really beautiful question as well, and we should film this question too. Oh, we're filming already? Because this is a nice question. There's a question with the bottles. Where is the question? Oh yeah, page 246, number 18. I love this question. A good question. You guys should put this stuff up for sure.
Green, brown ball.
Page 246, 18.
Now, refresh my memory as to the question.
How many different ways are there of arranging 7 green and 8 brown bottles in a row so that exactly 1 pair of green bottles
7 green and 8 brown, yeah, in a row.
in a row so that exactly 1 pair of green bottles exactly 1 pair of green bottles
1 double G.
side by side.
Okay, I'll do it. Think about it. You think about it. You want double greens, right? Only one. Okay, so I'm going to do this. If there are 8 brown, right? Could you have a double green before the single brown?
Yes.
Sure you could, right? So let's do this.
You have 9 positions.
So if you think of these slashes as gaps, there's a gap following every B. So if there are 8 B's, then there are 8 gaps afterwards. But I'm putting a gap at the front too. So there are 9 gaps, right? Similar to that question. So you have 9 positions now. But again, here, the positions are more than the actual. Or was that a head scratch or was that a hand up? I don't want the hand up now, Milan. Susan, you can put your hand up later.
That was a head scratch.
Oh, was it a head scratch? Go ahead, scratch all you. Okay, so, like, if you have 7G in total, that's going to become 7 take away 2. Never mind, the enthusiasm is good. 7 take away 2 is 5. Put back the 2 as a double unit. So that gives you 6. We need to fill up 6 of these gaps. 5 of the gaps are going to be like singles, right? I don't know. 1, 2, 3, 4, 5. And then one of them has to be filled as a double. Agreed? And then the ones that aren't filled, they vanish and then the B's collapse. Agreed? But it doesn't say anything wrong with B's being next to each other, right? And if you follow that way, you'll only have double G. You can never have triple G, right? You can only have double G or single G. So now it really becomes a question of, I guess, how many ways you can. It becomes a way of an issue of which of the positions you're going to choose, right? Again, just like before. Before I was like, I had 6 open slots, 2, 3, 4, 5, 6. Which 3 of the 6 slots am I going to take to fill up with letters? Now in that case, well, the difference is the following. Again, we have 9 slots, right? We have 9 slots. Shut me live, it's annoying. You have no. You have 9 slots. See, before over there when I was doing it that way, he was ripping it to pieces, and then when he saw it was right, now he's ripping off the ideas like, aren't you six? Aren't you six? So we have 9 slots, and I've got to take 6 of them, right? I've got to take 6 of them because there are 6, but wait a minute. There's more here. Because the way I take them matters. Because it's not just enough that I say, oh, I took position 1, 3, 4, 5, 8, and 9. There's more. Because that will give you, what is 9 choose 6? What number is that?
84.
84? So there's a tree with 84 branches. See, you have a tree with 84 branches. And all that tells you is which 6 positions you chose. But the thing is, let's say here you have a branch. Let's say this branch is P1, P3, P4, P6, P7, 1, 2, 3, 4, 5, P8. There's more that has to come off that branch. Because for that branch, where is the double G going to go? Right? Is the double G going to go here? Is the double G going to go there? Is it going to go there? Where is it going to go? Right? So, how many positions are there here?
6.
There are 6 positions, right? And one of those 6 positions is going to get the double G. So let's say I could put double G in position 4. If I put double G in position 4, guess what all of the other positions get filled with? G's, single G's. Is there more than one way of filling the remaining positions with single G's? No. So the only variation there is which of those 6 positions are you going to fill with a double G? So there are going to be 6 options for this to put a double G in, but then 6 options for this and 6. So I think that's it.
Yeah, that's it, sir. 504, that's a lucky one.
We can also do 9p6 divided by 5 factorial.
Yeah. That's the way I saw it. By the way, for any of these questions, I'm not saying the way I do it is the way to do it. That's just the way I saw it. There are different ways of seeing these things. You guys, Eric, did you follow it?
Yeah, but like, when you just say 6, that's like, does that mean like 6, C1? I mean 6, would that work?
You can think of it as 6C1, in other words. You agree with this? This is one of the, this is what is 926? 84. So there are 84 branches here, where each of the 84 branches is telling me which 6 of the 9 slots I'm going to fill up. But then branching, so one of those branches could be, oh, I choose slot 1, 3, 4, 6, 7, and 8. But now you have to, you don't just fill them one way. There are different ways you can fill them. How many ways you can fill them? Well, what are we filling them with? We're filling them with one set of double G's, and the rest are going to be single G's. Right? So 5 single G's and 1 double G. Where can the double G go? At any of the 6 slots. So you can think of it as 6 choose what. Which of those 6 positions am I going to choose for the double G? That's what this means. Which of those 6 positions for that first branch am I going to choose for the double G? Once you've filled it, you have 5 positions left. But is there any variation in which you can fill them? No, because guess what they all just get dumped with? G. And all of those G's look the same. So this 6, so you get a branch of 6 coming off of here. 1, 2, 3, 4, 5, 6. But guess what? Off of each of these, you also get a branch of 6. Right? And a branch of 6, and a branch of 6, and a branch of 6. So it's 84 branches of 6. I don't know if that helps. Wait a minute. Let's put the desks back.